Hello everyone, welcome back to Students Teach Orgo. Today we're going to be covering Fischer esterification. What do we do in Fischer esterification? We create esters using a carboxylic acid and an alcohol. So whenever you see a carboxylic acid and an alcohol, a little bit of acid, right, you will create an ester. So we take our carboxylic acid and we essentially create this ester group here. So this occurs in acidic conditions, meaning you should see no anions, and there does exist an equilibrium. So this reaction is reversible, unlike saponification, and the mechanism would simply be done in reverse. So we actually drive the equilibrium of this reaction to the right using an excess of alcohol. So the more alcohol we use, the more esters we'll get. We can even form cyclic esters known as lactones. We'll go over that in a bit. So let's go over the mechanism. So it's basically the same acronym that you've been seeing in this entire carbonyl unit, PATED. Protonation, attack, transfer, elimination, deprotonation. Transfer step, so we can deprotonate and then reprotonate, but we like to write that as one step. So remember, it involves carboxylic acids and alcohols. Don't confuse this with acetal formation, which is with ketone, aldehyde, and alcohols. Okay, so we want carboxylic. So whenever you see carboxylic acids and an alcohol, Fischer esterification. Whenever you see ketones, aldehyde and alcohols, think acetal formation. All right. So first thing you do is you protonate the carbonyl. Remember, you protonate the carbonyl. Then you have this attack with your alcohols. The alcohol attacks, kicks these electrons back up. Then you have this proton transfer that exists. So this was your alcohol originally, and it's going to get deprotonated, and this former carbonyl is going to get protonated. Then you eliminate a water. As always, you eliminate a water, you form a stable leaving group. Eliminate the water using a lone pair of electrons on the molecule. Make sure you always do that. And finally, you deprotonate, and you have your ester. Pretty sweet reaction. All right, let's go through a practice problem. Predict the product. Let's go over the answer. So I'm going to do this problem using a mechanism just to show how we get the final answer. So even though, yes, you can see that, okay, I'm going to connect this OH with this carbonyl, and I'm going to form a 1, 2, 3, 4, 5, 6-membered ring. Right, it might be a little hard to see that first. So what do? Protonate, then attack. So this is, at this point, is where we create the 6-membered ring. And then you have your transfer, because you have this diol, and you got to kick out one of those alcohols. And then you eliminate the water, as always. Deprotonate, and you create your lactone. All right, hopefully that makes sense. Let's continue to practice problem number 2. Okay, let's say for this same problem, if we radio label the oxygens below, what are the possible products we can attain? So I want you to think about this. Take some time, think about it. Let's see what the answer is. All right, let's move on. Okay, so this slide I know can be a lot, but basically, the whole point of this top part is I'm showing you how to get to this intermediate. And I have the oxygen labeled. So we attack, form our ring, and we get to this intermediate. It's kind of like diol with protonated ether. Okay, so 2 routes from here. 1, this oxygen can grab it, O2 can grab it, or route 2, this oxygen can grab it. And then everything else proceeds the same way. You kick out of water and deprotonate. And you form this product at the end. Same steps overall, right? It's just you have to choose which oxygen is the one that's grabbing that proton in the intermediate. All right, hopefully that makes sense. Let's move on to number 3. Predict the product of the following reaction. Okay, let's continue. So in this case, you're basically just going to get, you have 2 carboxylic acids, you have an excess of alcohol, both esters are going to be formed at both carboxylic acids. That's pretty much it. Just trying to show you that both carboxylic acids will get ester formation. All right, so let's do practice problem number 4. So let's predict the product using 1 mole of each. All right, and the reason why I say that is because you could dimerize. If you have multiple of these guys, you could create dimer. So predict the product using just 1 mole of each. All right, let's move on to the answer. So all we do is we just attach this guy, replace this OH with this, pretty much. And we create this ester here. Now, if you were to create a dimer, so let's just say if I had this reaction in reality, if I didn't have just 1 mole and I had multiple moles, right, and there was some cross reaction, I could actually do Fischer esterification with the dimer, meaning this alcohol can perform Fischer esterification, and you're going to get a lactone. It looks like this. Oh, like that. You're going to get a lactone that looks like that. So please try to figure out the mechanism as to how you get that kind of lactone if you were to use more than 1 mole of each. But for this problem, all I wanted you to know was that you can just attach a isopropyl group onto the to make an ester. Okay, great. Let's move on to practice problem number 5. So please synthesize the following molecule using reactants containing only 4 carbons or less. Take your time. This is quite an involved synthesis. All right, I'm going to start going over the answer now. Let's see. So the easiest way, in my opinion, to do this is you need to work 1 to 2 steps backwards and then forwards. That, I think, is the easiest way to do this. What do I mean by that? Well, I mean break the ester. That's the first thing we should do. So if I break this ester, this is going to be my OH, and this is going to be my OH here as well. So you're going to get your carboxylic acid, your OH, because this is Fischer esterification. So we're making an ester. Right? At the final step is making an ester. So this step is making an ester, right? So by breaking it, we get here. Go back. We get this. And I think this product is a little easier to figure out how to synthesize. So what I did was, okay, this looks quite familiar. I can basically just add CO2, so carbon dioxide. If I have lithium there, so I'm going to use this as my starting group. That's exactly what I did here. Use that as my starting group, and I use bromine here. You have to apply your protecting group first. You can't apply your protecting group after the lithium because then it's going to eat the carbonyl immediately. Then you create this sort of product here. Then you're just going to apply CO2 and H+. So if you're not familiar with this reaction, please head on over to carboxylic acids video made by Marco. And you create this sort of carboxylic acid with the protected aldehyde. You're going to react it with some H+, remove that protecting group, and then just to get here, we just need some sodium borohydride. Sodium borohydride is just going to turn this into an OH, and we get our final precursor to our Fischer esterification, and then usually a little bit of acid to do that intramolecular Fischer esterification. So this is probably a little bit more on the involved side, but it's still very much a problem you may see in your exams. All right, good luck with everything. Thanks for watching.